Morning, grade 11s. Welcome to online school. So I was looking through the workbook and I thought maybe I should just go over a couple of things to, just in case you're a little rustier at trig than you thought. So one thing to start off with is the good old Pythagorean theorem. I want to show you 3 ways it's written. If you didn't take a picture of the green poster, I'm going to write those out for you. So a squared plus b squared equals c squared. That's the one you're always going to get on your formula sheets and stuff in the textbook. But here are 3 really nice variations of that. So squared plus b squared. So this is for finding the hypotenuse. Okay, that is probably pretty obvious, right? You just go through, you take the square root of this stuff, and if you're into algebra and stuff, you know that to take the square root of that loses the square, you just get c, but then you have to do the same thing with that side. And I always put brackets around it. It just makes life a little easier if you have maybe a calculator that works funny with order of operations. Okay, so that's that one. Here's another one. A equals the square root of, again, c squared minus b squared. And another variation, it's the same thing. It doesn't matter if A or B, right? As long as it's not the hypotenuse, it's one of the other sides. Your formula is going to be c squared again minus a squared. Okay, so those are really handy, and I find it useful to have those written on my study sheet, and that way I don't have to try and figure those out algebraically, right, when I need to use those. I'm going to do a question for you from the workbook, so I'm on page 202. If I flip back, actually, I'm looking through. It seems like from the start it's just sort of reviewing this stuff, pretty straightforward. And then as I get to page 201, the example there, the example on page 201 is crazy. So try that. It's crazy because there's so many triangles. And instead of working through that with you, I'll leave that to you. I'm going to do question 3 on page 202. So the first question with multiple right triangles. So if I go to that, I'll leave that be, and I'm going to go right here to 202 and number 3. Okay, this is grade 11 trig because it's got multiple right triangles. Here's a really good strategy I've used, and here it is. Strategy. You want to pull individual right triangles out of the picture. Okay, now what that means is I'm going to look inside here and I see 2 right triangles. So I'm going to draw those separately. And so it takes a little extra time, but it's worthwhile. And then I label them. So X, and I've got 33 centimeters. I know it's a right triangle because that's right, so therefore that is right. It's the same, the rule. Remember the rule that this is 180 degrees, that's 90 degrees, so 180 minus 90 is 90. You know all that stuff, right? So that's where that comes from. But then, here's where it gets cool. I'll draw this triangle here, and don't worry if they're in proportion to each other. It doesn't really matter. It's just rough. It's helping you out. 35 degrees, and I've written over that. What's that? 19. 19. Now, when I look at those 2 triangles, I can't solve the one on the left because there's not enough information. I've only got a side. And if I'm thinking back to grade 10 trig, I needed a side and a side. That would be solvable. I need a side and an angle. That would be solvable. I don't have that though. Kind of have the 90, but I would love to have one of those or those. Now, if I look at the right triangle though, the right of those 2, this one's good. I have a side, I have an angle. So remembering back from last year, my strategy always was circle the angle and then look around and label stuff. So this is adjacent, so I'll put an A there. Now, if I think ahead, if I'm going over here to find X, what gets me there? Well, look at this. This and this are a common side. So if I can find that side, I can then move it to that triangle, and away I go. So, what is that? Well, that's the opposite, right? Angle, opposite. So opposite and adjacent, if I think of SOHCAHTOA, that means it's the tan function. So tan of 35 equals opposite, which I don't know, so I'll just use a letter. I'm going to use y, because x is used over there. No reason. Use your own initial if you want. And over 19. So then I get my calculator. Tan 35 times 19 equals y. I've got to grab my calculator. And so here I go. 19 times the tan of 35 is 13.3. So y equals 13.3. I guess it'll be centimeters. And then I can move that over here. So what I would do is I would probably just label that right here, so I can then visualize what my next step is. So this is 13.3 right there. Now I've got a side, I've got a side, I've got this. So that would be Pythagorean theorem, right? And so I'm going to just, again, if I go back, I should have my, this is the one I want, my formula, right? So I'll take that one, and I'll just punch it in. So C equals the square root of brackets 13.3 squared plus 33 squared. And the cool thing is on your calculator, you can do it all in one step. So I'll go second square root, 13.3 squared plus 33 squared bracket, enter, and I'm getting 579. So I'm going to just round to one decimal because that one's one. I think that's fine. So that equals 35.6 centimeters. So I solved it. Strategy was split them apart, solve the one that has enough stuff, which was the right hand one, and take the solution, add it to your second, the left triangle, and then use whatever strategy you need to solve that. In this case, I used tan, and then I used the Pythagorean theorem. Okay? So it's a little more work than last year. You've got to be a little bit methodical. Take some like methodical steps slowly, and draw it out. Use some scrap paper or use your workbook pages. Okay, we'll check in again with you in a couple days, maybe tomorrow. Email me if you have any questions. Okay?